Alright, so in this video we look at the volume 2 part of functions. We look at composite functions, we look at inverse functions, and we look at when x is as a value, what do we do? How do we substitute x to find the value for y? We will look at inverse of a composite function and so on. So here we go. Inverse of a function. There is two simple steps in finding the inverse of a function. First, we know that f of x is actually y, so we need to put y. Step 1, interchange x with y and y with x. Where you see x, you put y. Where you see y, you put x. So let's do this in the first step here. So this is x is equal to ay plus b, just an illustration. And the second step is to make y the subject of the formula, and that's it. How do you do that? You first take over the b, so it becomes x minus b is equal to ay, and then you take over the a, so x minus b divided by a is equal to y. So f inverse, written like that, f inverse x is equal to x minus b divided by a. There's another way of doing this. I'll show you it in this example here. So inverse of a function. How do you find the inverse of this function? First, this is y is equal to 4x minus 3. f of x is y. Then we interchange x with y and y with x. So this is x is equal to 4y minus 3. And then we bring over the 3. Then we make y the subject of the formula, the second step. So to make y the subject of the formula, we take everything over the other side and leave y by itself. So x plus 3 is equal to 4y, and then you bring over the 4, x plus 3 divided by 4 is equal to y. So f inverse x is equal to x plus 3 divided by 4. Now, there's another easy way of doing it using a flow chart. If we start with x, we want to see what is done to, what's the first thing that is done to x, or the closest term to x, closest element to x, and that will be the 4. So x is first being multiplied by 4. Multiplied by 4. So that's why you have 4x. Then after you have 4x, x is then being subtracted by 3. So that's why you have, I'm doing this wrong, let me do it again. We start with x. First of all, x is being multiplied by 4, so that's why you have 4x, yes. Then x is being subtracted by 3. That's why you have 4x minus 3. And that is the function. Now, if you're going to find the inverse, we move backwards. First, again, we start with x. So you do the last thing first and the first thing last. So x is being multiplied by 3, and we got to do the opposite of this. So then it has to be, 3 has to be added to x. So they have to have x plus 3. Right? So you do this, the opposite of that. And then you will multiply by 4, so it has to be divided by 4. So x plus 3 divided by 4. F inverse x is equal to x plus 3 divided by 4. Now this only works for linear functions that are in the form of y equal mx plus c. It doesn't work for those other kind of function that have some complications like these here. The flowchart don't work for that. Okay, so you are given the task to find g of x, g of minus 2. G of x is equal to 5x plus 1. So this is g of minus 2 is equal to 5x is minus 2 plus 1. And this is minus 10 plus 1, which is 9. So wherever you see the numbers, we replace the numbers with x with the numbers. You can find the inverse of that. using the flow chart because it's a linear equation, but we're using the two-step formula. So y is equal to 5x plus 1, interchange x with y and y with x, and then we make y the subject of the formula. So this comes over equal to 5y, and then the 5 comes over, so we have x minus 1 divided by 5 equal to y. G inverse x is equal to x minus 1 divided by 5. So that's the inverse. So now we're doing G inverse of minus 3 of 3, G inverse of 3. So G inverse of 3 is equal to 3, because x is there. Let me put x minus 1 over 5. So G inverse of 3 is 3 minus 1 over 5, which is 2 over 5. And as simple as that. Okay, so this is where some persons would get confused, but don't get confused. The formula remains the same. If you were to find the inverse of x, y of f of x, y is equal to 3x plus 2 over 2x minus 5. We interchange x with y and y with x is the first formula. So x goes there, equal to 3y plus 2 divided by 2y minus 5. The x, they had two x's, so we have to put two y's where the x were. So, and then we make y the subject of the formula. So to do that, we have two y's, so we have to bring them together and factorize them. And you have to check algebra, changing the subject of the formula to see how to do this here. So let's bring the y's together. First we have to move the denominator, so this becomes x times 2y minus 5 is equal to 3y plus 2. We have to expand here, so this becomes 2xy minus 5x is equal to 3y plus 2. And we bring the y's together because we can now move. We could move this 5 because it was in the bracket being distributed by other distributive law of x. So now we can move it because it's just connected by a subtraction sign. So the y goes, 5x goes over, 3y comes over. So we have 2xy minus 3y is equal to 5x positive sign change plus 2. Now we have the y's on the same side, so we can factorize them. So y comes out, and we have 2x minus 3 is equal to 5x plus 2. And then we take over this bracket here, so y is equal to 5x plus 2 divided by 2x minus 3. So f inverse of x is equal to 5x plus 2 and 2x minus 3. And that's how you find the inverse. Same two-step. Replace x with y and y with x, and make y the subject of the formula. So let's do this one quickly. Y is equal to, you do this one, and then you stop the video, solve this question here, find the h inverse of x, and then you play the back. Alright, so interchange x with y and y with x, y over 2y minus 1, and make y the subject of the formula. Denominator has to be removed first. X times 2y minus 1 is equal to y. 2xy minus x, x times 1 is x, is equal to y. So we take over the x, bring over this y. So we have 2xy minus y is equal to x, positive x. Factorize the y. 2x minus 1 is equal to x. Y is equal to x. Wait a minute, this is funny. So we take over this 2x minus 1, and it becomes x divided by that. So G inverse of x is equal to x divided by 2x minus 1. That is the exact same thing there. So the inverse of this function is the function itself. So now we want to find G inverse of 2/3. So replace x with 2/3, so 2/3 divided by 2 times 2/3 minus 1, 2/3 to the top. This becomes 4/3 minus 1. This is fractions, so this is 2/3 over the LCM. If we should work the bottom separately, the LCM here is 3, so 4 minus 1, the LCM is 3. 3 into 3, 1, 4. This is over 1, 1 into 3, 3. 3 times 1, 3. So this is a quarter. Good. So something is, yeah, this is okay. So this is 1/4. What do we do when we're dividing fractions? We upturn the second fraction and we multiply by the first. Right. So 2 3s, 8, 3 3s, because we couldn't cancel. So this is 2 and 2/3. Yeah, so that is done. Good. Next we go on to composite functions. What is composite function? What does the word composite mean? The word and this is found on page 808. Composite means to compose. Compose means to bring one or two or more things together. So composite function is bringing two functions together. Okay, so we're doing this here, and this is another illustration again. Then you see the actual thing here. We'll do one illustration, you do the other one. So we're composing f g of x. So there's two functions here, f of x and g of x, and we're composing them. You should note that the function in front here goes into the function at the back by replacing x. Now let me show you that. The function f of x is on this side, so this is ax plus b, and the function g of x is on this side, and g of x is cx plus d. So this is g of x. This function, when composing, goes into that function by replacing x. So we have a cx plus d plus b, acx plus ad plus b, and that's how you compose the function. Try that one. Let's see an example here. F of x is equal to 3x minus 1 and g of x is equal to 2x plus 5. We want to do f of x, and this is fg of x. Good. We want to put g into f, so let's put on f. F is on this side, g is on the other side, 2x plus 5. G goes into f by replacing x. So this is 3 times 2x plus 5 minus 1. 6x plus 15 minus 1. 6x plus 14. Right. 2 is common, so you can take out the 2x. 3 plus 7. But you don't have to take out the 2. Good. Then we have to find g of x, g of minus 3. So we already have f of x. So f of g is 6x plus 14. So you have to replace x in 6x plus 14 with minus 3. 6 times minus 3 plus 14. 6 times minus 3 is 18 plus 14. And this is minus 4. The question: if we had put minus 3 into g first and then take the answer there and put it into f, will we get the same thing? Let's see. So we have g f of minus 3. So let's take the g over. G is 2x plus 5, and we're dealing with minus 3, so this is 2 times minus 3 plus 5, which is equal to minus 6 plus 5, which is equal to minus 1. Right. Now, f of x, this is the g of x. So let's say we put an equal sign there. Let's say we took the g of minus 3 over the equal sign, and we got this here. Now the answer we got for g of minus 3 is minus 1. Now we're putting the f of x over, which is 3x minus 1. But this answer is minus 1. So it's 3 times minus 1 minus 1, which is minus 3 minus 1, which is minus 4. So we'll get the same answer. Alright, so you do g of x, put g into x, pause the video, do g f of x, right, and then you continue. So g f of x, be g first. G is 2x plus 5, f is 3x minus 1, so here goes into there by replacing x. 3x minus 1 plus 5 outside, 6x minus 2 plus 5. 6x plus 3. This is the gf of x. And well, 3 is common, so x plus 1. Alright, and then you put in the minus 3 and see what your answer is. So, I was thinking about not doing this here because these type of functions you won't see in the exam. The one that you see specifically in the exam is probably this one here. But I'm going to do this. So we want to evaluate f of a half and h of minus 2. F of x is minus 3 over 2x plus 1. F of a half. Now replace x with a half. So half minus 3 divided by 2 times a half plus 1. The 2 and the 2 cancel, so we have 1 plus 1 at the bottom. At the top, a half minus 3 will be minus 5 over 2. You do the LCM calculations. And this is over 2. The 1 from this here plus the 1 there. And when dividing fraction, we upturn the second fraction multiplied by the first. So this is 5 over 2 times 1 over 2. So this is minus 5 over 4, which is minus 1 and a quarter. And if we're doing h of minus 2, h is, you guys can do these things, man. H is 5x plus 3 divided by 2x minus 2. 5 times minus 2 plus 3 divided by minus 2 minus 2. Right. So we'll get minus 10 plus 3 over minus 4, which is minus 7 over minus 4, which is positive 7 over 4. Then they want us to find gh of minus 2. We already know gh of minus 2. That is that. So we don't need to go calculating this again. Nor do we have to go doing the composite function of gh. All we have to do is replace h of minus 2 with its value, which is 7 over 4. And then replace in g the 7 over 4. And you work out these fractions. So this will be 21 over 4 plus 1, and the bottom will be, let's work out the fractions separately. Let me work them out, work out the fractions, work out these fractions separately. So these are the answers for the fraction. So this will end up being 25 over 4 divided by 3 over 4, and then we have to upturn the second fraction and multiply by the first. 4 cancels with the 4, and we have 25 over 3. And that's what they wanted us to prove or show, that GH of minus 2 is equal to 25 over 3. Then finally for this video, we're going to do inverse of composite function. Right? So we first find the composite function, and then we find the inverse of the functions, and then we compose them. So f inverse of x is what we're looking for first. Y is equal to 3x plus 2. X is equal to 3y plus 2. X minus 2 is equal to 3y. X minus 2 divided by 2 is equal to y. So this is f inverse of x. X minus 2 divided by 2. Let's find g inverse of x now. So y is equal to 2x minus y. X is equal to 2y minus 1. X plus 1 is equal to 2y. X plus 1 divided by 2 is equal to y. Fg inverse of x is equal to 2x plus 1 divided by 2. Good. So we have the two inverse. Now let's compose the first one. I'm only composing the first one and then doing this, and then you'll do the second one. So we need g fg inverse. We need f inverse g inverse of x. So let's put them side by side. X minus 2 divided by 2 and x plus 1 divided by 2. So this function goes into that function by replacing x. So this is x plus 1 divided by 2 minus 2 over 2. Let's work out the top. So this is x plus 1 over 2 minus 2. The LCM is 2. 2 into 2, 1. 2 into 2, sorry, 1 into 2, 2. So this is minus 4. This is x minus 3 over 2. That's the top. So the top, and this is 1 over 2 over 1. So when we put them back together now, it is x minus 3 over 2, and we have to upturn the second fraction. So this is x minus 3 over 2 times 2 over 1. Sorry, 1 over 2. And this multiplies that because we can't cancel. So we have x minus 3 over 4. Good. So f inverse g inverse of x is equal to x minus 3 over 4. And then we have to do it with the minus 2. So this is f inverse g inverse minus 2 is equal to minus 2 minus 3 over 4 equal to minus 5 over 4 minus 1 1/4. And that's it for inverse function, composite function.